Hi everyone, welcome to lesson 3 in the fluids chapter. This lesson is on buoyancy. In this lesson, what I'd like to do is define what the word buoyancy means and then talk about the buoyant force and finally wrap things up with discussing the displacement of water when you submerge an object within it doesn't have to be water, but within a liquid. So to start off, the main term that we're going to be using today is buoyancy. And buoyancy is just the apparent loss of weight of objects when they are submerged within a liquid. So when you dunk something in, let's say water, for example, it's going to appear to not weigh as much. On the right here, one of the little pictures that I have is an object that has a weight of 9.8 newtons. And you can see that the weight of the water is 9.8, but when you dunk the object into the liquid, the weight of it on the spring scale only appears to be 7.8, so it appears to be a little bit lighter. And that lightness, that apparent loss of weight, is what we call buoyancy. Astronauts actually train in a giant swimming pool that they have. It's called a neutral buoyancy lab, and it gives them the appearance of being weightless because there's a buoyant force acting on them. They appear lighter than they are, so they can simulate space. The reason that objects appear lighter is because there's something called a buoyant force. Buoyancy is caused by the buoyant force. The buoyant force is when a liquid exerts an upward force. I think that that's an important point, so I'm going to underline that. An upward force on a submerged or partially submerged object that is opposite the direction of gravity. So if we take an object that's in water, and let's say it's a rock, there's going to be weight, which is m times g. That's the weight of the object that's gravity's pulled down. And there's definitely a buoyant force that's pushing up. Now, if that buoyant force is not as big as the weight, the object will sink. And that's what happens to rocks usually. If you put something in that the buoyant force is equal to the weight, then it will actually stay at the exact same level. It won't change, kind of like a submarine can float at any depth. And if an object's thrown into, let's say, water, and the buoyant force is bigger than the weight, the object will actually float. So we'll talk a little bit more about sinking and floating later, but that's the general idea. The bigger the buoyant force, the more likely you are to have something float. Now, where does the buoyant force come from? Well, earlier on in this chapter, we talked about how at different depths, there's different pressures. And the deeper you go in the liquid, the more pressure there will be. So when you have an object, and you put it in water. So we take an area of water here, a volume, and we place an object in that water. The higher parts will experience low pressure, but the parts that are deeper, even just a little bit, will experience a higher pressure. And that difference in pressure creates a slight upward force that we call the buoyant force. And this happens for any object that has some size to it. It doesn't matter what the material is. It's all about the size of the object. Cork, aluminum, lead, they all weigh different things. The cork would probably float because the buoyant force is greater than its weight. The lead would sink because the buoyant force is less than the weight. But these would all experience actually the same buoyant force because they're the same size. And there's a difference in pressure between the top and the bottom. So that's where the buoyant force comes from. Now, I think one thing to realize about the buoyant force is that it only depends upon the volume of the object. It does not depend upon the depth. At very shallow depths, an object might only experience a little bit of pressure on top and a little bit more pressure on the bottom. So here you can see with the arrows that I'm drawing on object A that there's only really a pressure differential of 1. 2 arrows on the bottom to 1 on top. Object B might experience a pressure of 2 down and 3 up. Has a little bit more pressure on the bottom than the top, but it's only by a difference of 1. And then object C might experience a pressure of 3 down, but 4 up. And the differential in the pressure, which creates the buoyant force, is only 1. So it really doesn't matter on the depth of the object. It matters the volume of the object, which is what's important. Finally, one of the last terms that I'd like to introduce in this lesson to prepare us for talking about sinking and floating is something called displacing water. When an object is submerged in a liquid, it displaces a volume of water that is equal to the volume of that object. So what I mean by that is that if you place a rock in this water, imagine this container filled to the top with water, and then we decide to put a rock in there. That rock is going to take the place of some of the water that was there, and that water has to go somewhere. It is displaced. It's moved to another area or to another spot. And if this rock had a volume of 1 liter, what we know is that it will move exactly 1 liter of water to a new place. It would displace it someplace else. And this is very important for understanding sinking and floating. And this is one of the ways that we can discover the volume of an object. We submerge it in water. If the rock had a volume of 2 liters, it would displace 2 liters of water. Or if it had a volume of half a liter, it would displace a half a liter of water. So in closing, here are some of the key points to buoyancy. When an object is in a liquid, it experiences an upward force that we call the buoyant force. Any object in any liquid will experience a buoyant force. The buoyant force depends upon the volume of the object. It also depends upon the liquid, but in most cases that's water, so it really depends upon the volume of the object. And when you submerge an object, it will displace a volume of that liquid that's equal to its own volume. These are the keys to buoyancy. I hope that this helped you a little bit, this video helped you, and you should try to complete the Lesson 3 quiz on Google Forms to show me that you know some things about buoyancy. Thanks.